morning, students. I hope I am audible. Good morning. Okay, so 37 students have joined, so we can start. Anybody remember what we did in the last class up to where? Physical characteristics, I think we have completed. Chemical characteristics, so I think we did. Total solids and suspended solids, then pH. Up to pH, I think we have done. Am I correct? Yes, this one said yes. Okay. So up to pH we have done. Let's start the next one. So next one is your after your total solids and suspended solids and pH. Next one is your hardness of water. So sometimes I think most of you have heard people saying that this water it is hard. Okay. So what does that actually it means? So what does that actually mean is that suppose when you mix, actually what needs to be happen is that when you mix water with soap, it should it should form some foam. Okay, it should create sufficient foam or lather. So in hard water, what happens when you mix your soap and water, sufficient foam or ladder formation doesn't happen. Okay, so it prevents the formation. The hardness, what it does, it prevents the formation of a ladder or foam in the water. So we can say that water it is hard. Okay, and what causes your hardness is due to the presence of your calcium and magnesium salts. Okay, when calcium and magnesium salts are present, in that case your water it is said to be hard. Okay, and also there are two types of hardness. Okay, number one is your bicarbonate. Number one is a temporary hardness, or also you can say carbonate hardness, and the other one is your permanent hardness, and also you can say it to be non-carbonate hardness. Okay, so first you see what lines you can write from here. You can write this hardness in water is that characteristic which prevents the formation of sufficient lather or foam when such hard waters are mixed with soap. Okay? It is usually caused by the presence of calcium and magnesium salts present in water. After that you can also write like for if hard waters it is present in a greater extent, or some hard waters are used in a greater consumption, then what will happen, it will cause corrosion and incrustation of pipes. Corrosion everyone knows, and incrustation I have explained in that last class is that in your pipe some white deposits are settled, or it is formed some white deposits, so that incrustation of pipes, which can they can lower the life of that design period of that pipe. Okay, and it can damage. So next is your temporary hardness. You see, if bicarbonates and carbonates of calcium and magnesium salts are present, you need to remember this. Okay, anyhow, you need to remember bicarbonates and carbonates of calcium and magnesium. If it is present in water, then the water it is known as your temporary hardness. Okay, and why it is called temporary hardness? Because temporary hardness of water can be removed. Okay, it can be removed by either boiling the water, or by adding lime to the water. Okay, so that is why it is known as your temporary hardness. So next, let's see. Okay. Here you see temporary hardness. It is also known as your carbonate hardness. Okay. Also known as your carbonate hardness. Next is your permanent hardness. So in permanent hardness, if sulfates, chlorides, and nitrates of calcium or magnesium are present in water, then it is known as your permanent hardness or non-carbonate hardness. You need to remember these two lines, okay? For your temporary hardness, bicarbonates and bicarbonates of calcium and magnesium salts are present, and in your permanent hardness, sulfates, chlorides, and nitrates of calcium or magnesium salts are present in water. Okay, and temporary hardness is also known as your carbonate hardness, and your permanent hardness is also known as your non-carbonate hardness. And permanent temporary hardness it can be removed by boiling the water, or by adding lime to the water. And also permanent hardness it can also be removed, but not by such an easy process. Okay, some treatments are there for removing your permanent hardness. Later you will come to know there are three four methods, like zeolite exchange, zeolite process is there, iron exchange process is there, okay, demineralization is there. So later when we will study about the treatment of water chapter, then you will come to know about all this. Okay, so there is a certain formula for finding out the total hardness in water. So this is the formula. You see, this is the formula. Okay, you can write it down, or you can take a screenshot. I will provide this PDF. Okay, that I am giving you now. I will provide this PDF in your group later. Okay. Okay. Then next, let's see. So what's the permissible limit for your this hardness? Permissible limit is, you see here, the prescribed hardness limit for public supplies ranges between 75 to 115 ppm. Okay, you need to remember this. The permissible limit should be remembered, 75 to 115 ppm. So next is your chloride content. So, chloride, everyone knows, in water, chloride is present in, in the form of sodium chloride. And what is sodium chloride? Sodium chloride is your normal or common salt. Okay, and if chloride is present in water, you can say that that water or that river is polluted. Either you can say it is polluted due to sewage or due to industrial waste. Okay, industrial and domestic waste or due to sewage, that river it is polluted. Clear? So in water, the chloride content, it should not exceed 250 milligram per liter. Okay, if the concentration it is above or it exceeds 250 milligram per liter, what will happen? It the drinking water or the water, it will have noticeably, it will have a salty taste in drinking water. Okay, and salty taste, if it is there in a drinking water, it is not recommended. People will obviously not drink any salty water. So the permissible limit for chloride content, it is below 250 milligram per liter. You need to remember up to here. Okay, so what you can write down is that chlorides are generally present in water in the form of sodium chloride, common salt, and may be due to leaching of marine sedimentary deposits, pollution from seawater, brine, or industrial and domestic waste. Okay, their concentration above 250 milligram per liter produce a noticeably salty taste in drinking water and are thus objectionable. So here this one, this line you can add: the chloride content of treated water to be supplied to the public should not exceed a value of 250 ppm. Okay, okay. Next is your nitrogen content. Let's see. Okay, so you can write from here. The presence of nitrogen in water is an indication of the presence of organic matter. Okay, so if nitrogen content it is present in water, you can say that there it is in that water organic matter it is present. And nitrogen, it can presence of nitrogen, it can be in any of the following four forms. Okay, so number one is your free ammonia or ammonia nitrogen. Second one is your albuminoid or organic nitrogen. Third is your nitrites, and fourth is your nitrates. Okay, so first one, free ammonia, you see, uh, the presence of free ammonia, okay, in water indicates the start of decomposition of organic matter. That means the presence of ammonia, if there is ammonia in water, it will indicate the start of decomposition of organic matter present in water. And for potable waters, the permissible limit for your ammonia, free ammonia, it should not exceed 0.15 milligram per liter. Okay, and the free ammonia, it can be easily measured by simply boiling the water and by measuring the liberated ammonia gas by distillation process. One process is there, distillation process. In that, by that process, you can measure the liberated ammonia gas. Okay. So next is your organic nitrogen. Okay. So you see. The presence of organic nitrogen in water also indicates pollution and presence of undecomposed organic matter. So, if organic nitrogen or albuminoid is present in water, that means you can say that that water is polluted, and also that water it has undecomposed organic matter, and the permissible limit for organic nitrogen is what? It should not exceed your zero point 0.3 milligram per liter. Okay. Next is your nitrites. Okay, so I can just say that nitrites, the presence of nitrites in water, it is highly dangerous. Okay, so the nitrite, it should not be present any water. Okay, any water should not present nitrites. Okay, because it is highly dangerous, and so the permissible amount of nitrites present in water, it should be what? It should be zero. It should be nil. Okay, and on the other hand, your nitrates. Okay, nitrates, what it represents? What it represents? Your fully oxidized organic matter, and if nitrates are present in water, then that water, it is not harmful. Okay, and moreover also, if you know the permissible limit of nitrates is there. Okay, the permissible limit for nitrates is your 45 milligram per liter. Okay, so if 45 up to 45 milligram per liter of nitrate is present in water, then it will not cause any harm. But if more, 50, 55, 60, 65 or amount of nitrates is present in water, then what will happen? Nitrate, it affects the infants. Okay, it affects the babies. How it affects? It causes a disease named as methemoglobinemia. Okay, this is the scientific name, methemoglobinemia, and commonly it is named as blue baby disease. Okay, and what happens in blue baby disease is that the children or the child, it may vomit, they may vomit, or their skin color, it might become dark, and sometimes what happens, in some rare case, not rare cases, in some cases, some children, they may die also if excessive amount of nitrates is present in water. Okay, so your amount, the prescribed amount for nitrates is your 45 milligram per liter. Okay, so this much is about your nitrogen content. Next is your metals and other chemical substances. So in water, some chemical substances or the metal ions are also present. So let's see what are the names of those metals. You see here, iron, manganese, copper, lead, barium, cadmium, arsenic, selenium, okay, fluorine, etc. All these metals are present in water. Okay. Last is your dissolved gases. Okay. So some dissolved gases are also present in water. So what are those dissolved gases? You see, nitrogen, methane, hydrogen sulfide, carbon dioxide, and oxygen. So all these gases, okay, these what it gets dissolved in water, okay, due to the interaction of it with atmosphere or the ground surface. Okay, so these nitrogen, methane, hydrogen sulfide, carbon dioxide, and oxygen, these are also present in the water. So what happens if hydrogen sulfide gas is present? You see, if hydrogen sulfide gas, I know everyone knows the smell of a rotten egg. Okay, rotten egg, everyone knows there is hydrogen sulfide gas. Okay, so it's such a bad smell. Yes. such a bad smell, if such a bad smell or taste it is present in water due to hydrogen sulfide gas, nobody will consume that water. Okay, so this hydrogen sulfide it needs to be removed. Okay, then presence of carbon dioxide gas indicates biological activity. Okay, if carbon dioxide gas will be present, so it says that it will indicate biological activity of the microorganisms that is present in the water. Okay, so if biological activity if is happening in the water, so that will impart your bad taste and odor to the water. Okay, and it may also cause corrosion. Okay, then uh, okay, so this much, and one more is there. If oxygen, sorry, just wait. See here. If the oxygen present in water is found to be less than its saturation level, that means what level is should be present. If it is found to be less than the saturation level, so it indicates the presence of organic matter and consequently making the water suspicious. Okay, so this much is about your dissolved gases. Okay, so we have learned about your chemical characteristics we have completed. So you make a note, okay? You make brief notes. I will share this PDF. So the important points you write it down, and also the permissible limits are important. Okay. Next is your, and one more thing. Next is your biological or bacterial characteristics. Okay, bacterial characteristics or biological characteristics. This one it is very simple. Okay, it is about your bacteria, viruses that are present in the water. Okay, all this like bacteria that are present. Okay, so you can means you can read this part by yourself. Okay, so I won't go much deep about this bacteria and viruses. Okay, so just I from this part I just want to explain one thing. These three bacteria I would like to explain. So in water, bacteria, they are divided into three types of bacteria on depending upon the oxygen necessities. Okay, so number one is your aerobic bacteria. So what is aerobic bacteria? The bacteria which require oxygen for their survival. Okay, for survival they need oxygen. And anaerobic bacteria, these bacteria they can survive without oxygen. Okay, they can survive without oxygen. And facultative bacteria is what? These those bacteria which can survive with or without free oxygen. That means they can live with oxygen, or also they can survive without oxygen also. So those are named as facultative bacteria. Okay, so these three types are the types of bacteria depending upon the oxygen consumption. Next is your waterborne diseases and control. This one is also a very simple one. Everyone knows what are the diseases that are caused due to water. Okay, water borne diseases everyone knows. So let us see the names. What are the diseases? Number one is your diseases caused by bacterial infections. Okay, so one is your typhoid. Everyone knows typhoid, paratyphoid fever, then cholera. Okay, cholera. Then bacillary dysentery. Okay, and you should know the name of the scientific name. Okay, what causes typhoid fever and what causes paratyphoid fever? It is due to Salmonella typhi bacteria. Okay, and what causes cholera? It is due to Vibrio cholerae bacteria. Okay, all these things you should remember the scientific names. Okay, then diseases caused by viral infections. Okay, infectious hepatitis or infectious jaundice, then poliomyelitis. Okay, third one is your diseases caused by protozoal infection, that is your amoebic dysentery. And what causes amoebic dysentery? It is due to your Antimida histolytica germ. Okay, you should remember these scientific names. Then, after writing all this part, the prevention, okay, the preventive measures are given. You can write it down now. Just take a screenshot or later I will share it to you. Okay, these are the preventive measures. It's already given. So you study. Okay, this part is self study. Okay, these are simple. Okay, you can study by yourself. Okay, 5 points, 6 points you write down and in your copy. Okay. Okay then. So with this we end our today's class also, and also we have the characteristics we have learned. So next class we will learn about the important part of your first chapter, the most important part of your first chapter, that is your treatment of water. Okay, treatment of water we will learn in your next class. Okay, so let me take your attendance. Why writing in the chat box? I will take it now. Roll number 69, 51.
51 present, ma'am.
Okay. 52,
69 present.
69 present.
Ma'am, 51 present, ma'am.
Yes, ma'am.
Okay,
69.
okay, okay. Okay, both 69, 51 present. Okay. 52, 52 to 60. Who is present?
Rambai. Rambai.
Ma'am, 54 present, ma'am.
54.
61 present, ma'am.
Wait.
And
54 is present.
61.
Yes, ma'am, 54 present.
Okay. Then who is
Ma'am,
present?
57 present.
Ma'am, 57 present.
57.
57. Okay. 57. Then 59, 60, etc. Right? 61. 61. Arif Khan.
Present, ma'am.
Okay.
Present, ma'am. 61.
62.
Yes, ma'am.
63.
Yes, ma'am.
Okay. 64. 65. 66.
Yes, ma'am.
67.
Present, ma'am.
68.
Present, ma'am. Ma'am, 59 is present, ma'am. 59.
What?
59 is present, ma'am. 59.
59. Osborne.
Roll number 59 is present, ma'am.
Okay.
It's present.
59. Osborne is present. Okay. Okay.
Yes, ma'am. It's me.
Okay. Then roll number 70. 71. 72.
Present, ma'am.
73.
Present, ma'am.
74.
Present, ma'am. 74 present.
Okay. 75.
Present, present, ma'am. 75.
Okay. 75%. 76.
Present, ma'am.
Okay. 77. Danger present. Okay. 78, 79, 80, 81.
Ma'am.
Yes.
Present ma'am. 81.
81 present. Okay. 82.
Present ma'am.
Okay. 83.
Present, ma'am. 83.
Okay. 84. 85.
Present, ma'am.
85 present,
85,
right?
ma'am.
Okay. 84 also present. 85 present.
85.
Okay. 85 present.
Okay, ma'am.
86. Likha. 87.
Yes, ma'am.
Okay. 88.
Yes, ma'am.
Okay. 89. 90.
Present, ma'am.
Okay. 91.
Yes, ma'am.
92.
Present, ma'am.
Okay. 93.
Yes ma'am.
Okay. 94. 94. Nanu
Ma'am.
Temtian. Okay. Present. Okay. 95.
Present.
Yeah. Present. 95.
Yeah.
95 absent or present?
95. Present, ma'am.
Okay. 97.
Present, ma'am. 97 present.
Okay. 98. Likha Tagu. 99. Oh, sorry. 98 or 99. Suraj Jamatia. 100. Okay. 99 present. Okay. Okay. 99 present. 100. 101. 102. 103.
Present, ma'am.
Okay. 103 present. 104. 105.
Yes ma'am.
Okay. 106.
105. Present ma'am.
Okay. 107.
Yes ma'am.
Okay. 108. 109. Atul.
Ma'am.
Okay.
Present, ma'am.
Okay. Then 110.
Present, ma'am.
Okay. Triple one. 112. Sabina. 112.
Yes, ma'am. Present, ma'am.
Okay. 113.
Present, ma'am.
Okay. 114.
Yes, ma'am.
Okay. 115. 116. Okay. Okay. 117.
Present, ma'am. 117.
Okay. 118.
Present, ma'am. 118.
Okay. 119.
Present, ma'am.
Okay. 120.
Yes, ma'am.
Okay. Now who is left out? Okay. I am reading out the absent ones you see. 52. 53. 55. 56. 58. 60. 64. 65. 70. 71. Then 78, 79, 80,
Present.
86. Who is present?
Ma'am. 80,
80.
80.
Okay, 80 present.
Yes, ma'am.
Then 86, 89, 98, 100, 101, 102. Then 104, 108, 111, 115, 121. Okay, others I have marked present. Okay. Okay then, let's end our today's class. Okay.
Ma'am,
Yes.
ma'am, roll number 71 is also present,
71 is present.
but I think his network is not good. Yeah.
Okay, 71 present. Okay. Any other? Just then, Arif analysis is okay. Okay then. So let's end it up. Okay. Thank you.
अनुव्यू विमल कर रहे हैं